Hello YouTube, welcome back to the desk, which serves as my bench, serves as my computer desktop. Really appreciate you subscribers coming back. I realize the channel, we do a lot of different things here, musical, mechanical, electrical. This is going to be an electrical video. In this video, we're going to get into the QDuino, which just showed up. And I'll get into the marvels of this little device. It is quite a cool little device. Before I do though, let me just give you kind of a preview of what's coming up. While I was waiting for parts to show up, I did a couple things. I debugged this board for my modular synthesizer. This is not for the modal, this is for a modular synthesizer. This is a Synthesis Technology MOTM 300 Ultra VCO, Ultra Stable VCO. I was having trouble with this board. You can see I had to patch it with some wire. It's pretty ugly, but I got it to work. And so the question is, what are we going to do with it from here? Well, I actually have another one that I got. So here's another board that I built from scratch. Same board, MOTM Ultra VCO. So now I got two of these VCOs, and I need to mount them into something. So I've got a mounting plate here, and that's fine. So this board can go on the mounting plate. We screw it in, the holes all line up, and then inevitably it's got to go into a front panel. This is not the front panel for it, but inevitably it's got to go into a front panel that I can use. So we've got a couple of things to do here with these VCOs. One is I've got to manufacture a number of these mounting plates. I've got to probably finish fleshing this guy out. He needs his pots put into there. And I need to make myself one of these, or two of these, for these VCOs. Now, I've got the raw materials. I've got the aluminum. I believe this is 5/16 aluminum. And it's a 2U rack mount size. And I'm going to have to powder coat and put some numbers and stuff on them. So we're going to go through a video on how to powder coat this. And I don't quite know how I'm going to do the white numbering yet. Going to figure that out, but this in a future video. So we'll be coming up with the mounting brackets for the VCOs. I've got a number of other things too. Here is a Catgirl synth sub oscillator and mixer circuit I got to build, or I got to build out. Actually, the board's populated. I now have to come up with a panel for it. And here is a cool Tom Oberheim class filter that I got off of the synth website. Bought the board, populated myself. Interesting here, I had to get some old transistors. I had to find some new old stock transistors to put on there, and a number of other parts. So that's all populated, ready to go. You saw last time I actually got the Ultra Psycho LFO working. And so that's got to get a front panel put onto it. So all this stuff here has got to have brackets and front panels made. And we're going to learn this kind of together. I know how to make the brackets. I've actually got a sheet metal brake I can use, and I can use the mill to drill the holes. I've got the raw material for the aluminum to make the front panels. Got the powder coating equipment. Got to figure out how I'm going to put these nice letters on the ones that I make. And we'll go through that in a future video. And another future video we're going to do is we're going to get into the modal and more music on the modal synthesizer. But for now, let's do a real quick vid on this here, the QDuino. So the QDuino is an Arduino knockoff, actually a knockoff of the Arduino Mini. It is, the pinouts are very familiar to anybody using Arduino. Actually very nicely so. As you see on the front here, they have the Arduino numbering. Here's D4. D14, D16, D15. So all the I/O is labeled on the board itself, which is really nice if you're trying to figure these things out. And as you know, with Arduino, some of the pins have dual purpose. So on the back here, here's the SPI interface pins all listed: S clock, MOSI, MISO, and reset right there. So they've lined the pins up so that the SPI is on the back and the digital I/O is listed on the front, and they're aligned on the board so that you can just look on the back and see what's what. So you've got SPI, you've got your I2C, you've got all that labeled here. So it's really done in a very ergonomic way to make it very easy for you to hook things up to this. And there's software in the Arduino library that will allow you to set up a fuel gauge and whatnot. And by fuel gauge, I mean it will tell you how full the battery is. Does the battery need to be charged, or is it ready to go? And that's really important, because if you've built a lot of Arduino projects, you know that in order to, especially these battery-powered Arduino projects, if you want to use one of these so-called Lipo batteries, lithium-ion little batteries, these are 3.7 volts. You tend to find them in cell phones, whatnot. They come in different configurations. That's a small one. Here's a larger one, and I got these from SparkFun, in fact, and I'll put the link up so you can find it. So this is 3.1 watt hour size, and this little one is a 110 milliamp hours. Okay, clearly less capacity, but still 3.7 volts, 3.7 volts. And there's a charge controller on the board itself. So the charge controller not only handles charging it, and you charge it by plugging your USB into this small USB mini right there. You charge it by plugging USB into there, and that 5 volts gets regulated down and charges the battery. So you don't need a separate board. And if you've done these projects before, you'd know that you need an outboard little charge controller. You'd have to get a separate circuit board to do that. They're not that expensive, but you got to get a separate circuit board. You got to hook them up. In fact, my last Arduino project, I had to do that, and it just adds the size and the inconvenience. This is all on one board. Now, you program this exactly the same way as a regular Arduino. There's no difference. You use the standard Arduino IDE. The one thing I did find is that you can't use the current IDE. Now this is today. Okay, now so the current Arduino version as of today, which is January 23rd, 2016, is Arduino 1.6.6, and I can assure you right now with the software that is currently available, it does not work. You will not be able to compile and load, and in fact I will show you the error that you get. I've reported it, and apparently the error has to do with something that's deep in the Arduino code, and the QDuino developers can't figure out, or it's difficult for them to figure out how to get around it. So I've plugged in the QDuino here to, let's see, you'll see some lights. There is a red one and a green one. We'll get into what that is in a moment. And plugged it in there, and if I try to hit the upload button here, you'll see that I get an error, and the error is right here, visible in the Arduino IDE. See that focus. Wow, that's not so bad with the focus on the screen. And you get this, cannot run program, blah blah blah. There's a scripting problem somewhere in there. I don't know where it is. Couldn't fix it that way. The way I can get this to work is by going back to the older version of Arduino 1.6.4, and that will work. Okay, so QDuino did not work with Arduino IDE 1.6.6. On January 23rd, 2016, which it is today, it does work with 1.6.4, and the author or the designer of the QDuino said it also works with 1.6.5. I don't have 1.6.5, I got 1.6.4, and it works just fine. We can upload programs to it. So what you do is, highly recommend go to the, if you go to their Quick Start guide, which is at hackster.io. So hackster.io, go to the QDuino Quick Start guide. It'll show you how to set up the board in the board manager on the Arduino IDE. You basically add the appropriate URL to the preferences, and when you start up the board manager, it will load the QDuino QTechno board information, and then you just hit install and it works. And then what happens is when you go to your Arduino IDE, you'll find here in the tools, you'll see Arduino MIDI, QDuino MIDI will show up. There it is on mine. And then if it's plugged in, as mine is, and turned on, you'll see the USB modem, the USB connection right there. Right, so we're in. Now, one other thing I'll warn you about here is that the code that we're using for this battery level RGB was kind of munged up. So what we've got on the QDuino is, okay, so here's the schematic from the SparkFun website. This is called QDuino_mini.schematic. And there's no wires here, so you have to figure out what's connected to what by looking at these little input-output tags, right? So, what's happening here? All right, so first of all, let's take a look at what the processor is. The processor is an 18 mega 32U4. That's an 8-bit microprocessor, so this is not 16-bit or 32-bit. That means your ints, your integers, are going to be 8 bits. It's running at 3.3 volts and it's running at 8 megahertz. Not quite that fast, but on the other hand, not using as much power. So we got a lower power thing happening here. Okay, now the cool thing about this is where is the power coming from? And the neat thing about the QDuino is it really doesn't care. And I'm going to show you what I mean by that. So right now we're getting the 5 volt supplied off of the USB here. Standard 5 volts. I'm going to plug the battery in. Now, let me plug in the other battery. I'm going to plug this battery in. I have a reason for not wanting to plug that battery in a second. Alright, I'm going to plug the bigger battery in. Alright, so that battery's plugged in, and you'll see this is the status light. That's not programmable by the user, but this is the user light is programming. You'll see the user light's flashing. Alright, I'm going to unplug the 5 volts. And you're going to see the user light still flashing. It's still running my program off this battery. Nothing changed when I unplug the 5 volts, so that we're still getting continuity of service here, and it automatically switched. And that's pretty darn cool. We've got this little switch here. We can turn it off. I can turn it back on again. And it'll reinitialize. It starts off red, and then after 5 seconds it starts flashing again. See? So now we're running off that battery. Now how did it do that? Well, alright, so let's get this power thing straight. So the AT Mega and all the other components on the part want to see 3.3 volts. That's coming out of this regulator here, this VCC here, through something called VN. So VN might not be 333 volts, but you better expect that VCC is going to be 3.3. V input comes from this auto switching circuit, which there's a little FET here, and that's switching between two things. You're either going to get the power through this thing called Lipo, or this thing called VBus. Now, VBus comes off of the USB. So when I'm plugged into the USB here, I'm getting 5 volts from the USB. Let's say this battery's not here. Well, not say it's not here. We'll actually take the battery out. So the battery's out. All right. So I took the battery out, and what we've got is 5 volts coming in. It's going in through the USB, right? And it's coming in through D plus and D minus. It's going out VBus, and VBus is being switched in here through the Zener, and it's coming out the V input, which goes into the regulator. If I put the battery in, something very interesting happens, but just for the moment, I'm going to take that out. So the battery's on and we're still running. We still have continuity, and I'll tell you why. So the little status light has gone dim on us because it knows it's running from the battery. It doesn't want to run down the battery, but this user light's flashing because that's what the program does that I set. And what's happening? Well, the Lipo is this battery here, and so what's happening is that VBus is actually VBus is nothing's happening to VBus. The charger circuit is doing essentially nothing now, and the power is coming in through Lipo, not VBus, and that's where V input's coming from. That goes to the regulator and comes out. So presumably we've got 3.7 volts on V input now, whereas before we had 5, right? And that's supplying VCC. So this auto switching automatically switches between Lipo, which is the battery, and VBus, which is this fellow here, which is the USB. Presumably it takes the probably takes the higher voltage, I'm guessing, is what that's going to do there, 5 volts, and then supply it through there. Now here's the other interesting thing that happens. If I've got power on VBus, it's going into this Lipo charging circuit. Now there's two cool things, two super cool things on, in addition to this auto switching on the QDuino. One is this Lipo charger. So if I've got USB plugged in, I've got 5 volts on V-bus, what that's going to do is through this charger, which understands the charge profile, and these start slow and build up, and here you can change these, you can set this to change the charge rate differently. You can charge either 100 milliamps or 500 milliamps if you want a faster charge, but it depends on whether or not you've got enough juice or not. And that goes to the Lipo, and so if I've got 5 volts in here, that's going into this battery, and it's actually charging this battery up. If I don't have anything here, nothing's going on there at all. And so the charger will automatically charge the battery when the USB is on there. And if you've built a lot of battery-powered Arduino circuits before, you've had to use an outboard charger circuit with this little thing on there. And a little outboard board. It's not that big, and it's not that you know, it's kind of innocuous. But you do have to have a separate board, and you have to hook it up. I wish I had the QDuino for my last project. It would have saved some space in the case that I built, because this has got it on board, and that's cool. But the other neat thing that you've got is this Maxim battery fuel gauge, this Max 17048. And what's happening with this guy is it's reading the battery voltage, and it's got programmed in it the tables for the charge profiles and discharge profiles of a battery like this, of this battery chemistry. And so it knows when it sees a certain voltage, is this battery 100% full, 75% full, 50% full, 25 or 0, and it'll take that number between 100 and 0 and output it on this I2C bus right here, this SDA and SCL, S clock, S data. Now, along with the QDuino is a bunch of software that will takes care of reading that stuff for you. You don't have to set up the I2C, you don't have to set up anything, it handles it for you. And right here is the program that I got. So this is one of their example programs, and all you do is you set up a variable, here it's called battery, of type fuel gauge, which is presumably reading the data off this I2C bus. And then you set up another one called QDuino, which takes care of all the other software. And the other software essentially manages changing these lights to different colors and whatnot. And there's 2 lights. One is a status light that they control. I looked up in their software. I can't figure out how this, you can't mess with this light. But this one you control completely. And as you see, you can set the RGB, this is called RGB, so the user RGB can be set to different colors, and you don't have to, you can set it individual RGB percentages like with other software, or you can just say green, yellow, orange, and they've got a whole list of colors that you can pick. So that's kind of nice. You don't have to remember what, you know, that red is, you know, 10000 or something like that. You just give the enum red, and it figures it out for you. Okay, so the software takes care of measuring the fuel gauge for you. The hardware is taking care of the charger circuit for you. All that is automatic. You don't need any other software. You don't need any other hardware. It's all right here, and that's kind of convenient. Now, one other thing I'm going to show you here is in this program itself, which is called battery level to RGB. There were some errors in this code, and again, this is January 23rd, 2016. By the time you see this, these errors may be fixed in the code that they distribute. But one of the errors I saw was this one. So what they had here in both of these places was a double less than. And double less than is, as far as I know, a bitwise shift left. And if you try to do a bitwise shift left, this would say of 75 spaces. I guess if it shifts in 0, you're going to wind up with 0. In fact, I got nothing. I couldn't get anything out of this thing. So I don't know why that was there. Maybe that works in some other language, but it doesn't with Arduino. So you've got to take these double less than signs and make one just a regular less than sign, just one less than sign, right? That makes the conditional. And what this is saying here is I want to measure the charge percentage. So what is the the level of the battery as indicated by this fuel gauge here. And I'm going to get a number between 100 and 0. And if it's over 75, if the charge is greater than or equal to 75%, I'm going to set this user LED here to green. If it's between 50 and 75%, I'm going to set it to yellow. If it's between 25% and 50%, I'm going to set it to orange. And if it's below 25%, I'm going to set it to red. Okay, so that's kind of cool. So you can see with this is going to be like a little fuel gauge. It's going to tell you, red, yellow, orange, red. It turns ever so much more red as the battery is lower and lower and lower. And I'm going to show you how that works right now. Now, one last thing on the program. This program, when I got it, also did not have this line in here. There was no delay. Maybe this one was gone. In any case, what happened was there were no delays here. The LED was getting shut off, so it was getting set to something and was getting shut off, and then it was delaying, and you were winding up looking at nothing. So I bracketed this by 2 delays. I've got a 5-second delay with it turned on, just so for the case of argument, so we can see what the color is. In real life, you'd program this some other way. You'd have a button or something, because otherwise this is going to burn power on you, right? So you'd have some button that you'd push, and you'd see what the battery level was, and you wouldn't have this turned on all the time like I do now. But just for the sake of being accurate on this demo example, you want to change those 2 things. You want to take the double bracket, the double less than, and turn it to a single less than in all the places, everywhere. I think there was one down here too. And you want to put a couple delays in there so you can see what the LED is. You don't need them in real life. All right. Now, let's see this thing actually change color. What I'm going to do is I'm going to turn this off, and I'm going to take this battery out. Now, I think as I've shown previously, this battery, I had this resistor in here, and I was just discharging it so that, I didn't want to short it out. I didn't want it to burn up, but I put a little resistor in there. And I think this is like a 100 ohm resistor or something, just so the thing wouldn't get hot, but would discharge enough so that I could see the QDuino change color. So I've discharged it through that resistor. Now I'm going to plug it in here, plug it back in. That's the other real nice thing about the QDuino. It has this battery jack right in it. I mean, really, why didn't we think of that before? We've had those big circular jack things, in other Arduinos, which are kind of fun, but for the battery you need this, right? All right, now I'm going to turn this on, and you see it's red, but it's going to be red for 5 seconds because I've programmed 5 seconds in there. But it turns off, it turns on again, I still got red. So what that's telling me is that I've discharged this thing, at least superficially at this point, below 25%, and I should recharge. So if this was something that if this was a controller in some device that I built, and I saw that red, I'd say, uh-oh, sooner or later I'm going to go dead, so I better recharge this. So here's how you recharge it. You just take your USB, plugged into something. It doesn't have to be plugged into your computer. It could be plugged into your iPhone recharger or your Android phone recharger, whatever. Plug it in the USB. You're going to see the status light's going to get real bright because apparently when it's charged by the USB, they're not worried about running your battery down. So there we go. We get a bright light. So it knows that the USB is plugged in. We're still red, but we're going to see that change color. There we go. We're going to orange now, I guess is what that color is. Hard to tell. And as time goes on, it will, so we're being charged. Battery voltage is going up. Right? If I unplug that, let's see what happens if I unplug it. That's still orange. All right. It might go red, though. I've seen it go red after a few... Yep, there we go. We're back to red again. All right, so we didn't really get a charge in there. So you can see, though, how that's working. So we're charging this battery up now, and frankly, I'll probably just leave this plugged in so it charges up all the way. And this is really, really useful because I don't need to have a separate board for my battery power. Those boards are, by the way, available at SparkFun. I'll put the link over here, so if you want the charger boards for your other Arduinos, but the QDuino takes care of that for you. So, once again, in summary, you've got a nice Arduino. You can use the Arduino IDE. You've only got 32K program space on here. Let's see if we can see that here. Yeah, maximum, after after the Arduino core is taken up, you've got 28.6K bytes left. This little program just took 7K bytes, so not very much. And global variables, I didn't have very much myself, but I'm sure that these classes, this fuel gauge class and this QDuino, probably use a lot of globals somewhere, some globals, not a lot. In any case, it's a smaller processor than you're going to certainly find on your Mega, and probably also on your Due, maybe even your Uino. But you get, in return, what you get is a machine that runs at low power consumption rates, can run on these batteries, I imagine, for quite a while, and gives you automatic recharge, right? So there you go. That's the QDuino. Thanks guys and girls for watching. I got some musical things to do coming up. As I said, I'm going to do the modular synth. I'm going to do the modal synth. We do a lot of different things on the channel. I do a lot of different things on the channel. I appreciate it. Really appreciate that you come back, and I really appreciate that you subscribe. I know you're out there. Thanks for the comments, and hopefully you found this useful. Again, the QDuino. Thanks a lot, guys. See you later.